Now we're going to look at that second set of elements. And that's going to be, let's get you in here. So from this point up. So again, we're looking at, we can read this as parentheses here, any of these elements spanning from lithium all the way down here to cadmium will replace hydrogen from steam. Steam is when you have water in the gas phase. So again, it is very, very important that you pay attention to the states of matter, especially that water is going to be in. So water is going to be one of our key things to look at here. All right, so I would like for you to highlight steam, where it says steam. Right, and beside there you see in my handwriting it says H2O with a little G beside it. That means it's in the gaseous phase. And again, when these elements react with water, whether it's in the liquid form or in the gaseous form, they're going to form a metal hydroxide, that's OH negative, and hydrogen gas. So there will be two products there. Okay. So here we go. We have these guys. Each element in this section, so all the way from lithium all the way down to cadmium, will replace hydrogen from steam. And that is with the gas phase. So what we can do is, let's look at one and try this. If I have iron and I put it in some water, will I have a reaction? The answer is no, and this one was a little tricky, and the reason why is because of this right here. That is liquid. Only those elements from sodium up react with cold water. Iron is right here. It reacts with steam, but not with cold water. So, if I were to take this and I don't know if I can get rid of anything. Let's try this. And I rewrote it like this. Would we have a reaction? Yes. And let's say what we're going to form, let's say the most common form of iron is iron 3. So that's not something I would expect you to know. I'd have to tell you. So iron 3 plus, and it's a metal hydroxide. So iron is our metal, and hydroxide, OH negative. The sum of the oxidation numbers is not 0, so that 3's got to come down here. Fe, and don't let hydroxide get you, OH3 plus hydrogen gas. That is what it's going to form every single time. Now, again, you should feel that you need to balance this equation, and we do. I've got an odd number of hydrogens there on my product side, so I'm going to go ahead and even that up. And again, that just takes practice in looking at those. So now I have 2 irons. We'll go ahead and fix those on the reactant side. And now my hydrogens. I have 2 on the reactant side, and I have 2 times 3, which is 6, 7, 8, plus 2 more. So 8 on the other side. So if I put I'm going to have a 6 here to fill with my hydrogens. I probably need to start with my oxygens first because hydrogen's in too many things. So let's talk about my oxygens. I have 2 times 3 oxygens, so that's 6 oxygens. So let's go to the reactant side. I need 6 of those. So now I have 12 hydrogens over here. And I need to have 12 on this side. Here, 2 times 3, I have 6. And I need 6 more, so let's put a 3 right there. Well, that one was a fun one to balance. Okay. Now let's look at that next segment, and we're going to follow from this line, this one right here. Again, that means anything from the top all the way to this bottom line right here. So from lithium all the way down here to hydrogen. We'll replace hydrogen from acids. So what I'd like for you to do is highlight or underline with another colored pen, acids. And we know acids start with hydrogen, and so this tells you exactly what's going to happen. If one of these metals is put into acid, then the hydrogen is going to be replaced by the metal, and hydrogen gas will be given off. So let's see. Next, let's look at this. So each element in this section, from lithium all the way down to hydrogen, will replace hydrogen from acids. All right, so if I have zinc and I put it in hydrochloric acid, will a reaction happen? Yes. Zinc is within that span of elements, and it is going to replace a hydrogen. So hydrogen's given the boot. He's going to be that single element going home crying. And zinc is going to replace it. So it says the word replace. So that means it's going to take its place. Don't just smack them together. We know how to write formulas. Zinc, and zinc's oxidation number is something we should have memorized, is 2+. And then chlorine is a halogen, Cl negative. The sum of the oxidation numbers is not 0, so that 2 has got to go over here. So ZnCl2. Then you have to balance. My zincs are fine. The chlorines are out of whack, so I need to have 2 hydrochloric acids. That also takes care of my hydrogen. That one is balanced. Will copper react with sulfuric acid? And the answer is no. Copper is not within the span of elements, so this would be no reaction. It's below that line. Now, you can use it like that and read those words there, but you can also just use it like we learned how to use for basic single replacement reactions. Zinc is above hydrogen, so it has enough power to replace it in a single replacement reaction. So it can work just like that. Okay, now let's deal with the longest line that we have here. It's all the way from the top all the way to this bar right here for mercury. Any of these guys will react with oxygen. So oxygen is going to be another one of our key things, so we'll highlight oxygen. And now when oxygen is written as a molecule, remember that it is going to be O. Let's actually do that not in the highlighter. O2, because it is a diatomic. And when these elements react with oxygen, they are going to form that metal oxide. So they're going to form a compound with oxygen, just like ionic. So let's see. Here we go. These elements here that are on the left, each element in this section will react with oxygen to form oxides. So if I have, let's see, calcium, will it react with oxygen? Yeah, calcium is within that span of elements, so it is going to form an oxide, calcium oxide. Calcium is in group 2, so it's Ca2+. Oxygen is in group 16, so it's 2 negative. The sum of the oxidation numbers is 0, so CaO. And then I have to balance. Put a 2 here to balance out my oxygens. Now I need a 2 here to balance out my calciums. Like I talked about earlier, the least reactive elements, like the ones we use for jewelry, so here's gold, Au, will it react with oxygen? No, it's below the line, so we're not going to have a reaction here. And that makes sense because we can wear jewelry out in oxygen, so no reaction. All right. That is the basics for the activity series. What I'd like for you to do is I'd like for you to do these practice problems. Use your activity series, see if a reaction happens or not. If a reaction happens, I want you to complete it. So I want you to pause this podcast right now, and then I would like for you to try these guys, and then you can hit play and it'll show you the actual answers. All right, so So, working with aluminum and oxygen, if you look at your activity series, aluminum is within that realm of reacting with oxides, and a lot of elements do react with oxides. So what we're going to do here is it is going to form a reaction. So what we have is aluminum will react with oxygen, and so it's going to form an oxide, and that oxide is aluminum oxide. Aluminum is Al3+, because that's one we have memorized. Oxygen's 2 negative. The sum of the oxidation numbers do not equal 0, so you have to crisscross. It's Al2O3, and then you have to balance this. I have 3 oxygens on the product side, 2 oxygens on the reactant side, so I need to go with a common multiple, so 6. I'm going to try and get 6 on both sides. So if I put a 2 here, I can put a 3 here. And then I have 4 aluminum, so I put a 4 here. Lead and zinc. Lead is below zinc in the activity series. So this one is no reaction. C, rubidium and lead. I'm going to compare those two. Rubidium is above lead, so rubidium will replace lead in a single replacement reaction. And so lead is going home by itself. Rubidium is in group 1, so it is 1+, and nitrate is in O3 negative, so it's just RbNO3. Then we have to balance it. I like to start with my nitrates because it's kind of screaming at me. I have 2 nitrates on the reactant side. On the product side, I only have 1, so I need to put a 2 here and a 2 in front of the rubidium on the reactant side. Now D, if I put zinc in cold water, again, you must pay attention to what state of matter water is in, then what you're going to see is that there's no reaction here. Zinc does react with steam, but not with cold water. Copper and hydrochloric acid. Copper is below hydrogen, so it does not have enough power to replace it, so again, we're going to have no reaction. F deals with the activity series of the halogens. So that's that first activity series on your paper. Bromine is above iodine, so bromine will replace iodine, and it's often very, very helpful to just go ahead and draw that arrow like I did right there. So iodine is going home crying by himself, but he is diatomic, so it's I2. And then bromine is going to take its place. Potassium's still in front. Bromine will bond with it, so K+, Br negative. We don't just smack Br2 in there, it's Br2 because it is diatomic. But all bets are off when it's in a compound, so this is just KBr. And then I have to balance. I need 2 Brs on this side, that gives me 2 potassiums on the product side. I need 2 potassiums on the reactant side, and that takes care of my iodine as well. In G, we look, and water is one of our key words. It has to do with the lines on that activity series of metals. It is cold water. Sodium will react with cold water, and it forms sodium hydroxide, so metal hydroxide, and hydrogen gas. Then we have to balance that. I have to deal with my hydrogens. I need to even those up, so let's put a 2 here. That's going to give me 2 oxygens. If I put a 2 here, now I have 4 hydrogens on the reactant side. I have 4 hydrogens on the product side. And I just need a 2 here to balance out my sodiums. Chromium. Chromium will react with steam, not cold water, but steam it will react. And the most popular form of chromium is going to be, let's say, chromium 2. So chromium 2, again, I wouldn't expect you to know that. If you wrote chromium 3, that's fine. I would have to tell you. So it's going to make chromium hydroxide, so CrOH2, and hydrogen gas. Don't forget that hydrogen gas. And now we have to balance. I have 2 oxygens on the other side. If I put a 2 here, that gives me 4 hydrogens, and I have 4 hydrogens on the other side as well, and I am done. This takes a little bit of practice, so don't be afraid. You can run back through this particular PowerPoint and do it again.